Today we are going to discuss about height of a binary tree or depth of a binary tree. The height of a binary tree is the total number of edges on the longest path from root node to all leaf nodes. Consider the following binary tree. This is the binary tree where it is having three leaf nodes, where D is a leaf node, E is a leaf node, C is a leaf node. Leaf node is a node which is not having any children. All other nodes are non-leaf nodes. Now we need to find length of path from root node to leaf nodes. There are three leaf nodes, so we need to find length of three paths. So path. What are different paths in here? A, B, D. A, B, D. What is the other path? A, B, E. A, B, E. What is the other one? A, C. We have three leaf nodes. So root to leaf node, we count the total number of edges A, B, D, A, B, B, D, two edges. B, D, A, B, E, two edges. A, C, one edge. So length is 2, 2, 1. We have three paths. Length of first path is 2, total number of edges 2. Length of second path is 2, total number of edges 2. Length of third path is 1. So largest path is considered as height or depth. In here, the largest one out of these three is 2. So height is 2 or depth is 2. So height of the binary tree is 2 or depth of binary tree is 2. Calculating the height of a binary tree. We can calculate height of a binary tree using a simple recursive algorithm by finding the maximum height of left and right subtrees of a binary tree. For example, height of an empty binary tree is -1. In a recursive function, there will be a base case. It has to stop somewhere. So here, in this particular thing, the base case is height of an empty binary tree is -1. And if a binary tree is having only one node, the height is 0. Empty binary tree is having height -1 and a binary tree having only one node is 0. Then height of a binary tree, the recursive function is height of a node is 1 plus maximum of height of its left node comma height of its right node. This we can explain using this example. Suppose if we wanted to find height of this binary tree where a is root, so height of a is 1 plus maximum of height of its left subtree and height of its right subtree. Suppose if we know height of left subtree and height of right subtree, we take the largest value from height of left subtree and height of right subtree, then we add 1 so that it becomes height of the binary tree. It is given in here. Height of A is 1 plus maximum of height of B, height of C, where B is left subtree, C is right subtree. 1 plus maximum of, we take either height of B or height of C, the largest value we take, so that height of A becomes 1 plus maximum of height of B comma height of C. As it is a recursive function, as we don't know height of B, again we use the same recursive function to find height of B. Now height of B is 1 plus height of D comma height of E, 1 plus maximum of height of D and height of E. If we know the height of D and height of E, we take the largest value and we add 1 so that we get height of B. Again we don't know what is height of D. So to find height of D, we will have 1 plus maximum of height of its left subtree and height of its right subtree. Left subtree of D is null, right subtree of D is null. So to find height of D, we will have 1 plus maximum of height of its left subtree, height of right subtree. Height of null is -1. height of null is minus 1, right? It is an empty binary tree. So height of an empty binary tree is minus 1. So 1 plus maximum of minus 1 comma minus 1. The largest value out of 2 minus 1s is 1 minus 1. So 1 plus minus 1, which becomes 0. Height of D is 0. Height of E is 0. Then height of B is 1 plus maximum of 0 comma 0. Then height of C, it is a leaf node. Height of C is 0. Then height of A is largest of left height and right height plus 1. 1 plus maximum of 1 comma 0, 1. So height of A is 2. Height of A becomes 2. I will explain this even clearly in the next slide. Let me explain the recursive procedure to calculate height of a binary tree. Consider this binary tree to calculate height. In this, A is root node, D, E, C are leaf nodes. Left of D is null, right of D is null, left of E is null, right of E is null, left of C is null, and right of C is null. So this is a binary tree. We wanted to find height using recursive function. We wanted to find height of A. Height of A is 1 plus find height of left subtree and find height of right subtree, which will be 1 plus maximum of height of B comma height of C. If we find height of B and height of C, then find the largest value out of these two heights, add 1 so that you will get height of A. But we don't know what is height of B. It is a recursive function. So height of B, we are going to find height of B. So height of B is again recursively we can calculate as height of its left subtree comma height of its right subtree. So if you wanted to find height of B, that could be 1 plus maximum of height of its left subtree and height of its right subtree. That is 1 plus maximum of height of D comma height of E. Left of B is D, right of B is E. Height of D, height of E. Then we don't know what is height of D. Again, height of D, calculate height of D. Height of D is 1 plus find height of its left subtree and height of its right subtree. Height of left subtree is null, right subtree is null. That is empty binary tree. So 1 plus maximum of height of null and height of null. 1 plus maximum of height of its left subtree. Left subtree is null, comma height of its right subtree. Right subtree is also null. Height of null, comma height of null. So height of null is minus 1. Height of null is minus 1. Minus 1 comma minus 1. Height is minus 1. Maximum is minus 1. 1 minus 1, which is 0, which could be 0. Here also height of E. Height of E also. E is also a leaf node. So we find 0. We get it height as 0. C. For C also it is 0. Because we know what is height of null. Height of null is minus 1. Height of null is minus 1. See here, that is placed in here 1 plus maximum of minus 1 comma minus 1, which is 0. Height of C is 0. Height of C is 0. Then height of E is 0. Height of D is also 0 because D, E, C are leaf nodes. Height of leaf nodes is 0. Then what is height of B? 1 plus maximum of 0 comma 0. 1 plus maximum of 0 comma 0, it will be 1. 1 plus 0 is 1. Here height of C is 0. Then height of A is 1 plus maximum of height of left subtree comma height of right subtree. Height of left subtree B, height of right subtree C. So height of B is 1. Height of C is maximum of 1 comma 0. 1 plus maximum of height of B, which will be 1. Then comma height of C, which will be 0. Maximum of 1 comma 0 is 1. 1 plus 1, which will be 2. Height of A is 2. Height of A means height of binary tree. Height of binary tree is 2. So using this recursive function, we can find height of a binary tree. Then the base case is if we are going to find height of a null node or null tree or empty binary tree, which is minus 1. Height of a leaf node is 0. Height of null tree is minus 1. Then height of any other node is 1 plus maximum of height of its left subtree comma height of its right subtree. Let me explain the function to find height or depth of a binary tree. Height is treated as depth also. So height of a binary tree or depth of a binary tree. For this we need to find largest value of left height and right height. Left height is an integer, right height is an integer. So maximum of a comma b. Assume that a is height of left subtree, b is height of right subtree. This maximum function returns an integer, that is largest height. If A is greater than B, that is height of left subtree is greater than right subtree, return A, height of left subtree. If it is less than B, then it returns height of right subtree. So anyway, this returns you largest value. To find largest of two integers, the maximum function returns largest value. So using this, we are going to find height of binary tree using a recursive function. So height of P. So height of a root, height of a binary tree. Normally, a pointer is pointing to root node P or root. We wanted to find height. If it is null, means if it is an empty binary tree, it returns -1. Otherwise, it calls 1 plus maximum of height of P left comma height of P right. That is left subtree, right subtree. Find height of left subtree, find height of right subtree, find the largest value, add 1 so that you can get height of a binary tree. If it is, the base case is, if it is empty, if it is an empty binary tree, it returns -1. Otherwise, it calls again the same function to find height of binary tree using recursion. Here, suppose if we call height of A is not a empty binary tree, it is non-empty binary tree. So it calls return function, return 1 plus maximum of height of P left, A left is B, comma height of P right. P is here A right is C, height of B comma height of C. 1 plus maximum of height of B comma height of C. We don't know what is height of B and height of C. Again, it calls height of B first. Height of B. What is height of B? Is height of B null? No, it is not null. So it finds 1 plus maximum of height of its left subtree D, comma height of E. We know that height of D, it is not an empty binary tree. Again we find height of D. Height of D. Height of D is 1 plus maximum of height of left subtree and height of right subtree. Height of left subtree is -1, height of right subtree is -1. Maximum of -1 is -1. 1 plus -1 is 0. 1 plus -1, which is nothing but 0. So height of D is 0, height of E is 0, height of C is also 0. Then height of B is 1 plus maximum of height of left subtree comma height of right subtree, it is 0. It will be 1. Here height of A is 1 plus maximum of left height comma right height. Left height is 1, maximum of 1 comma 0. Left height is 1, right height is 0. So 1 plus maximum of 1 comma 0. 1 plus maximum of 1 comma 0 is, it returns you 1. 1 plus 1, which is 2. So height of this binary tree is 2. Height of this binary tree is 2. In this way, it finds height of binary tree or depth of binary tree. Thank you.